Right. So I'll start with, sorry, it's loud. Uh, 1 second. With a overview of, verifiable credentials and dates, what we saw yesterday, and some of it might be a repeat of what Andy said, but then once we get to a certain point where we covered the basics, I think I'll check in and see, if you want to deep dive in certain areas versus others. And if you have questions at any point, let us know. A presenter didn't show up, so we have an extra hour, so we can kind of be flexible about where we take it. And Andy's offered to join me to help balance different, different technical approaches to these standards. Okay, so the title of it is Deploying Decentralized Identities Authentication in DFS. We're going to talk about verifiable credentials in DIDs and see some examples of it, and then just go wherever you guys would like to. So yeah, we'll start with a reminder of intro to verifiable credentials. And then we'll talk about DIDs, but then also how DIDs and verifiable credentials work together. And then we'll see some examples. And then at that point, it would be good to just, sort of, we can do a lot of Q&A, things like that. So some of this is a reminder from yesterday, but just to refresh, what is a credential, because that term can be kind of misleading to people. And by that, we actually mean a range of claims that are made that you might want to carry around with you, and that other people might want to validate in some way. So this ranges from what you would call low stakes credentials, or like movie tickets, things like that, to work IDs, diplomas, insurance cards, or passports. So anything that nowadays relies on either just a visual verification, or, we're moving some of these, like with some passports are machine readable now. But so any credential of those kinds of varieties is an example of something that could be what we'll start talking about next, which is a verifiable credential. And so the value of the verifiable credential envelope, it's a very flexible wrapper. The whole point of it is put in whatever schema you want, and this is just a generic way to verify the claims that are in that. Curious if you have anything to add. Show your passport.
Yeah. Show my passport. Yeah, everyone's got a photo of my passport now. I think the thing here is a verifiable credential. Think of it as just a way to move some data in that is specially watermarked, so you can check it's authentic. The data could be anything, right? And we've almost got ourselves into trouble by talking about identity all the time, because identity credentials are only one sort of credential you can move. Like a movie ticket is not an identity credential. It's a credential that lets you get into a movie. So that's the thing to bear in mind. These things, they're like, there's a new way to digitally watermark data to allow you to check it's authentic. Just think of it like that. And that data could be anything. It could be an X-ray scan. It could be a picture of your cat.
And that's an important point, because I think a lot of people were talking yesterday about how identity is a fundamental layer of that. And to some extent, people in the decentralized identity space kind of cringe when they hear that, because there's a lot of things where people end up knowing all this stuff about you just for you to do a basic action, right? So I think that's one of the benefits of the zero knowledge proof kind of technique that he was showing earlier. Do you have to reveal everything about yourself to prove that you can do this certain action? So that sort of approach is really baked in, or kind of reflected throughout verifiable credential decentralized identifier design. So verifiable credential. So what we're just talking about, this part claim in the middle, that would be the payload, or the content representing, that the passport or movie ticket, whatever. But don't think of it as much as a literal, you know, machine readable form of that content, because part of the design of verifiable credentials is because the holder of the credential can in theory prove control over it, you don't need to rely on having a whole lot of personally identifiable information in there. So, you know, whereas your passport has a date of birth, you know, maybe the verifiable credential version of it doesn't. This is sort of a new sort of question that will vary per use case and per you know, government domain, etc. So a lot of those efforts are underway right now. What does the paper version of it look like in a verifiable credential format? So also in a verifiable credential is metadata. So the issuer, and those are represented with DIDs, and we'll see examples of that. When the claim expires, there might be a representative image or hash of an image, something that is in this signed payload. And then information about how to verify. We'll get to that in a second. But then lastly, revocation mechanism. So I think Andy was starting to, I think you were starting to talk about revocation and we didn't get there. So basically one of the benefits of having credentials anchored to a distributed ledger is that the distributed ledger becomes the place that the issuer can update to say, I'm revoking this claim. So if someone's, you know, to your point about, I don't remember what it was, of the
phoning home and.
Yes. So I think you also gave an example. Okay, so right, it was with maybe a driver's license.
Yeah. It was the doctor. Right? Yeah, the doctor's license to practice after he's killed a bunch of people.
Exactly.
Has to be revoked. Yeah.
Yeah. So that doctor in the verifiable credentials world, the doctor can still carry this verifiable credential form of it around, but in that credential, and part of the verification process is something saying, go to this location to check if it's revoked. And so that's something that is, that's one of the biggest benefits of using blockchain. And so that's one of the reasons of, you know, not everything needs to be on the blockchain, but the revocation information or some pointer to get that information, that's very easy for the issuer to update. And it doesn't necessarily rely on you contacting the issuer directly.
We should probably talk a bit about how revocation works.
Yeah, do you want to show something on it? Or?
I didn't connect my PC to anything, but I can describe it. I can describe it to you. As Kim says, the ledger becomes a place to put the revocation information. So when Dr. Andy is struck off, the medical license issuer, they have to put that information somewhere that Andy is struck off. Now, you have to be very careful about doing this, because if you put that information in a public place, then everyone can see that Dr. Andy has been struck off. Now, for doctors, that's actually okay, right? Because everyone should know a doctor has been struck off. But if I've had my license revoked for drinking and driving, I don't want the world to know that, nor should they. So this is why driving license authorities don't publish a list of all the people who've had their licenses revoked. And also it may be that I have gone on a terror watch list, and you don't want to publish that publicly. Yet you still need to put this revocation data somewhere, and here we're putting it on a publicly accessible ledger. So that there's this kind of dichotomy there. You're publicly saying someone is revoked on a public ledger, but you don't want anyone to see it. So what you have to do is you have to instead encrypt the revocation information in such a way that anyone can get it and verify a proof that you're revoked or not revoked without revealing who you are. Okay, so if that sounds like voodoo, it's going to get worse. So what happens is, and I'm going to oversimplify, so if there's any cryptographers in the room, I apologize. The issuer, when they issue a credential, every credential has a serial number, right? And if they want to revoke one credential, they add that serial number to a set of revoked credentials. And they then calculate what's called a cryptographic accumulator based on that set of revoked serial numbers. I see some nods in the room, right? And the cryptographic accumulator is like a long prime number. I'm generalizing here. But what it means is that when Kim comes to provide a proof to someone that she is a doctor, she's including a zero knowledge proof that her credential is not revoked. The recipient, when they get that, because they know the DID of the issuer, because that's encapsulated in the proof, they go to the ledger, they pull the public keys of the issuer, but they also pull the accumulation, the cryptographic accumulator from the ledger as well. And they're doing what's essentially a divide, right? They're saying, a bit like a prime number, does it divide by this thing in this proof? And if it does, then it's on the revocation list, and if it doesn't, it isn't. But what you've got there is a cryptographic accumulator, here we go, that you can't reverse engineer. So you can't reverse engineer it to find all the serial numbers of the people that have been revoked, right? But what you can do is do a divide with the special weird zero knowledge proof thing that enables you to check if the proof that Kim provides is from a serial number of a credential that was in the set that was used to calculate the accumulator. And that is called anonymous revocation.
One thing I do want to add to that, so that's the good way to do it. But the part of the idea that it's called out a revocation mechanism is that there are simpler ways to do it that are less privacy preserving. So, for example, the way some people do it is just a simple list of certificate IDs that have been revoked. So if those things are not correlatable, people say, that's good enough. But that way, you know, how do we really know what's correlatable in the end? So, yeah. So that's the basic way to do it, but it has concerns. That's a better way to do it. But revocation mechanism, that's flexible. Like you can, you know, if you come up with something even better than that.
Well, in fact, the first iteration of this anonymous revocation was actually computationally quite intensive. There's a new version being worked on. So anyone who wants to Google how this stuff works, Google AnonCreds 2.0, right? ANONCREDS. What you'll find is a whole bunch of maths. And the new version uses Merkle trees instead of this particular cryptographic accumulator mechanism. AnonCreds, ANONCREDS. Yeah, it's okay. It's a bit weird. AnonCreds 2.0. Now, Kim's exactly right. There are a lot of situations where it is perfectly feasible to have a public list of revoked somethings, right? So yeah, let me just type this. Anyway, I'll just leave it. It's just so you'll find it goes into a GitHub repo with all the stuff in there and so on. However, there's a whole bunch of things you can publicly announce are revoked, which you would publicly announce are revoked now, right? Like doctor licenses to practice. Okay, those you can just publish anywhere. And if you want to put them on a ledger, you put them on a ledger. But for those where you need to privately revoke things and not reveal the identity of the person revoked, then you need a more kind of sophisticated privacy-preserving mechanism. Okay? And that's how the revocation stuff works in Indy and verifiable credentials.
So the last part is the proof. So that consists of two things. So again, we call it proof. We used to call it signature, but that assumed a cryptographic signature, but they wanted to generalize to different forms of proofs. But the most common one would be you have a private key, or the issuer has a private key, and they sign the claim, and they put, the signature value in the proof area so that it can be independently verified against the issuer's public key. And so, so proof is two parts. So there's the integrity of the credential, it hasn't been tampered with, and then authenticity, that issuer who I expect to issue it really issued it. This is an example, this is a sort of behind the code of a verifiable credential. So there's verifiable credentials are a data model. In the verifiable credential data model specification, JSON and JSON LD formats are called out as examples. So this one shows JSON LD. Let's pretend it's JSON, because JSON LD is a lot to get into. We'll get into it later if you want to. But effectively, so in this we have the issuer, that's the DID of the issuer who issued the credential, and then the credential subject. So this credential subject ID, that's who received the credential. So that could be my ID saying I have a bachelor degree, sorry, the formatting is bad, the bachelor degree, a Bachelor of Science in Mechanical Engineering, and then the proof looks a lot like this. So there would be the signature value, there's a lot of characters that have been omitted, but let's see. Yeah, so this is, we don't have to worry too much about the fields here, because we'll get back to that. Okay, so this is another view, or sort of the verifiable credential decentralized identifier ecosystem. The subject, the recipient, that's me, say I got my bachelor degree. The university would be the issuer in that case. They would issue a credential to me, so I'm the subject of that credential. So the verifiable credentials data model calls out a possible separation between the subject and the holder. So holder would be relevant for, so actually Sovereign has a lot better examples than anyone else. So they could be useful in cases where, well, actually one of the use cases is a Sovereign one that I like a lot. So they have a Sovereign partner that they do DIDs for pets, right? And so your pet might get a prescription for medication, but your pet is not going to go into the pharmacy and go claim that that credential, right? So you would be the holder of that. You probably have a lot better example, but I like that one. I like DIDs for pets.
It's a really cool one. Like I said earlier on, this applies to people, organizations, and things. And a thing can be like a thing, like this, or it could be an animal. Okay? And the DIDs for pets, when that company first came along and said, we're going to do Pet ID, I just thought, you're insane. And then he explained the problem of pet passports and inoculation records and
breeding,
who owns the pet and all this kind of thing, and breeding and pedigree and so on. And suddenly you're going like, oh, okay, and it's an enormous potential business, so they're really onto something. But like you say, the pet can't present, it doesn't have a phone, right? Not yet. But the way that DIDs have been designed, are you going to be talking about guardianship?
No, I do not.
Okay, well, we should cover that a little bit. The way DIDs have been designed is that a DID can have a controlling DID. Okay? So you can have a hierarchy. So my pet can have a DID, and there can be a wallet with credentials in that maybe I have or is stored somewhere in a cloud, wherever it may be. But the pet's DID has a controlling DID, which would be the DID for me. So anyone who sees the pet DID can see that there's a guardian for the pet, which is me. And if they want to check that I am the guardian, they can send me a proof of that. Now, this is really important. So it's an interesting example with pets, but it also works for a baby who hasn't yet got their mobile phone. or
A minor even.
a minor or an elderly relative with dementia who can't remember anything. So essentially built into the DID protocol is guardianship, which means that you can assign cryptographically verifiable power of attorney. Okay? It also means a company can have controlling DIDs, which are the directors of the company. Right? So this kind of stuff's been, a lot of it's been thought about already, and there's a sovereign guardianship task force that's actually just reported its first output, and it's about things, the edge cases like refugees who haven't got a phone, yet they turn up at a Red Cross camp. They can be issued and have a wallet that the Red Cross owns, and the Red Cross is the guardian for them. But when the refugee does get their smartphone, then they can take the wallet and own it and manage it themselves. So that sort of use case. So guardianship is really important, where there are people without, mobile phones. Interestingly, 90% of the refugees, I heard this from Médecins Sans Frontières, 90% of the refugees coming into Greece from Turkey have an Android phone. Amazing, but so it is.
The question on that one, would it apply to, for example,
Yeah. So there's just been a really good project done by a Swiss organization called GLEIF, Global Legal Entity Identifier Foundation. And they are the overarching body for all the issuers of legal entity identifiers, which are now mandatory in many countries for organizations. So organizations have to have legal entity identifiers. And the project was to show a CFO of a company submitting their company accounts to a regulator. And the CFO could prove that they're the CFO because they have a phone with some credentials on it that say they're the CFO and says their name, etc. And says which company they work for. And the regulator could then send a proof request to the company, and the company has a wallet with credentials in, with its VAT registration, its company registration, its shareholder list, its credentials, and its LEI issued by an LEI issuer. And they can then prove that, so that the regulator now knows the company's valid and it's not a spoof company. And then, and you can go up the hierarchy. So if you're thinking in the banking world about corporate KYC, how do you know a company is a company? It's horrendous. It's far worse than knowing a person is a person, because you need to get to the ultimate beneficial owner. Right? So you need to chase up the hierarchy. Now, if you credentialize that whole hierarchy with credentials for the directors and the shareholders over, whatever it is, 10%, and the companies themselves, you can chase that hierarchy up in about a minute. So that's transformative. So the answer to your question is yes, it does apply for companies, and it applies for things as well.
And also to touch on sort of the ecosystem, let's stick with the pet example just because it's useful. So then my dog, my pug, gets a prescription for some medication. So I go to the pug pharmacist, and so that pharmacist would be the relying party. So this exchange credential line is referring to, if it's a verifiable credential, say I might be presenting it on my phone, but then, so the relying party would be suspicious, like maybe I tampered with it, right? So maybe it's just an image. So there's actually emerging protocol standards around that credential exchange, whereby the relying party can ask me to exchange my credential, and then they can challenge me to prove I control the identifier embedded in it. The relying party then, or software on their behalf, performs the verification. And this is the step we were just talking about, where they check the credential to see it hasn't been tampered with. They might consult the distributed ledger for information about whether it's been recovered. So that's where all of that process comes in. Yeah, this is just more details on that. So
We should talk about DDoS.
Yeah.
DDoS and credibility.
Yeah.
This the title for this thread is all about authentication, so we probably should talk about authentication a little bit. There's two ways you can do authentication in this new world of DIDs and credentials. The first way is called DidAuth, and the second way is called credauth. One uses DIDs and one uses credentials. So, as I said earlier on this morning, two parties can exchange private DIDs, doesn't touch a ledger, and then as long as you trust who I am, that DID connection we have is persistent as long as we want it to be. So when I come back again, all I need to do is prove I have the private key associated with the DID I gave you, for which you have the public key. So DidAuth is really simple. I can authenticate to any of the connections I have by signing a request with my private key. Now, we've done the first real-world test of this in the UK with the National Health Service and with Microsoft and an organisation called True, which is our doctor identity thing, where the doctor would accumulate a bunch of credentials that they're a doctor, medical degree, license to practice, criminal record check, clinical qualifications, all those credentials in a wallet. They then onboard to the hospital by proving they're a doctor by just a simple credential exchange. Now, once they're in, the hospital has a DID-based connection with them. So that can then be used as single sign-on to any hospital system. Right? So that starts to get interesting because the person is carrying around with them. So you essentially, with this, you've got universal single sign-in for everything, everywhere that supports DIDs. Right? That's massively, massively powerful. Yep.
Fine, but this requires so all the so you earn your credential. That means you earn it on your device.
Yeah.
The first question: if I have multiple devices, can I copy it across devices?
Okay.
Can you what?
Can you have? So I've got 3 devices.
Uh-huh.
So this is a multi-wallet scenario. Right? Do you want to do this one?
Oh.
So multiple wallets, right? So I've got 3 devices here on different ecosystems. I've got Android, I've got Windows, and I've got iOS. Now, if I was like an Apple fanboy, I'd have all iOS, and I'd have a keychain that's synced across all the different devices, right? But this whole world is not about being stuck in a silo, it's about being open. So at the moment, there is no ability, there's no multi-device sync across different wallets or multi-wallet synchronization. But there will be. So the group working on Hyperledger Aries is working on exactly this. So there will, at some point, there will be the ability for you to have multiple wallets that sync with each other. And the question is then, what syncs? Right?
So, and I'll add, there are several models for dealing with that, where this is an area that's very pre-standard, pre-standards. So there's some terms are encrypted data vaults is one approach. Microsoft's approach is called identity hubs. So in this, looking at the subject holder and the folder in the cloud next to it, that's an attempt to represent the credential doesn't have to be on your device. It can be in cloud storage, and there's a lot of emerging protocols and standards representing, the way that the wallet on your device fetches it from, the cloud. But the idea is so it could just be stored in Dropbox, for example. That is one way to do it, but the reason that there are emerging standards around it is the idea of enabling portability. Basically, the idea of if you were to do it right now, you'd have to use the Dropbox interface and know where that file is and all of that. But so if we live in a world where we have all of these credentials, we're wanting a more seamless interface, right? So, and in fact, we want it to happen behind the scenes. Like, we want the relying party to be able to say, I want to see your dog's prescription, and I don't have to browse for a file. Like, they'll say by type, and then my software agent knows, okay, look for a credential of this type and send it, right? So that kind of exchange.
So if I may, my next question then is about, it's all about the security assurance that you can have, and it's not just the app or the wallet, it's the device, it's yourself, it's this whole interaction. Because I'm in a security company since a long time, so for me, I'm always paranoid about when I see something which, frankly speaking, looks correct. I really like the intention, I like what I see, I'm really happy. But I know after 25 years indeed that nothing is correct. So I'm always trying to find where is the weak point, because at least I know. So if I would be a hacker, right, I could hack your device, I could mix into your user experience, I could hack your brain, that would try to do whatever type of misinformation or disinformation, not try to get you to vote for X or Y, but really like attack your brain, so make you believe you are going to do the right thing with your digital certificate, but in fact screw you, right? And then you are going to leak that somewhere where you should not. So because this is becoming if I would be a hacker now, that would be what I need to attack. So it's all good to raise the bar, but it's an arms race. So we are going to raise the bar for the attacker as well. So you can be sure that if they target you, you can be pretty sure they will succeed. It's a matter of how much effort and time they put in. So what would be your mitigation?
So are you talking about, well, so I'll say my general thought on it. So we're talking about a lot of new standards, a lot of new technologies, and I share your paranoia. You want something to be shipped and attacked in the world for a while before you really start saying, okay, go use this thing. So I think to some extent, if you're looking at it from a file level, the verification process is looking at that file and saying, verifying it cryptographically. But then you worry about things like, okay, so what if this attacker, really doesn't want my pug to get her medication, and so they hack into the pharmacy, they find an exploit to hack into the pharmacist verification software and like lie with a display or something like that. So I think that those impacts of the mixing the digital credentials with the human readable displays, I feel like we need to do a little more work there. For example, when I started with what's called block searches, credentials on the blockchain, I think because it stemmed from open badges, and one thing we realized pretty soon is that the content could totally be different from the image, right? So that's so we address that in one way. Verifiable credentials has a solution for it, but things like that are kind of underemphasized, and you have to realize that people aren't going to look at the JSON code behind it to make sure that it matches.
Yeah, I'll just come on to that. The most common question we get asked is, what if I lose my phone? Or what if my phone is stolen? It's the same sort of thing, right? There was a paper written on, you'll find it in the Evening blog, what if I lose my phone, if my phone is stolen. But it's all about minimizing, but you can't eradicate all possible risks, right? If I came and held a gun to your head and said, give me your wallet, your physical wallet, you would give it to me, right? And I'd go away and I'd have your credentials, I can pretend to be you. So that's the sort of best case at the moment, is you've lost all of your stuff, and you have to, what do? You have to go and reapply to the passport office, the driving license, and do all of that manually. In the digital world, first of all, I can have a backup so I can restore. Right? Secondly, the work going on, and you can contribute. This is all open. It's not just Evening, MIT, and so on. Anyone here, if you've got ideas, this is all open source stuff, so you can all contribute. So the ability for you to revoke your phone's ability to do something. So your phone, we call it an agent. This is an edge agent. Right? So they're looking at the moment at the ability for you to revoke your device's ability to respond to proof requests. Okay? But it's all about minimizing the attack surface from a big database full of stuff at some intermediary to my phone and my fingerprint and my iris. Now, sure, you can go and get my fingerprint and my iris, you know, and hold a gun to my head and take, but the economies of hacking become very different. You're going from getting millions of records to having to work really hard and be really criminal to get this from me. But you could still do that. And if you do that, then maybe I can revoke the ability for this to do anything. And the issuers of those credentials can revoke those credentials to make them useless. So you've got lots of other kind of angles of defense. And sure, you could have, you could, this is another thing to work in, is like a trusted execution environment. Okay, all of that. So still work to be done. Yeah.
Yeah, some have 3-4 questions on that aspect. So I agree with you that we have the option to revoke identities if we found out that they have been stolen. Sorry. One thing that bothers me is identities are very different from assets, like financial assets. If I take the example of Estonia, for instance, if you have the ability to steal an identity of a citizen and you still sign a contract with this identity, you are still legally bound to whatever contract has been signed with your identity. And this is in the law in Estonia.
Can I clarify? So you're saying, okay, I have an Estonian identity, someone steals it, but I'm still?
Yes.
Oh.
Yes. So
what happened is that must have happened, right?
It has happened.
So there must be some really upset people.
It has happened, and they have been people faced in really troublesome situation where they have signed the possession of a house and they don't have money to buy the house, and they are basically bankrupt.
Yeah. So could that happen? Ignore the digital identity. Could that happen with physical identity?
No, because with physical identity, when you sign a contract, you have what we call in cryptography the deniability option. A physical signature is deniable. A cryptographic signature, to have the deniable aspect on it, it's something in cryptography that is very specific. It's other algorithms which are completely absent in DLT worlds. We don't have deniabilities in DLTs. So that's something that I would be very curious to see how we can bring it there.
So were you in this morning earlier on? Okay.
Sadly not.
So what we spoke about this morning is the distributed ledger. All it's doing is holding some issuer keys. It's not involved in the exchange of credentials. Okay. So it's a different model to putting the credentials on the ledger and recording the transaction of the credential exchange on the ledger. In this world, the implementation where that I've been involved in, the credential exchange transaction never touches the ledger, and it doesn't need to, nor should it, because it's a private exchange. It's like me, if I showed you my passport, publishing in all the newspapers, I've showed you my passport. You know, why would you do that, right? So it's a bit different. You're not recording the transactions on the ledger. They happen off ledger. So maybe that would change the way that legislation works. I don't know. It's really interesting.
It's something that needs to be very cautiously taken into account.
Yes.
Sure.
When we deal with identities linked to DLTs, even if we avoid storing identities in DLT and we store only accumulators and englobing IDs of credentials, we also need to think of the consequences of what that means.
Yes.
Yes.
And the second aspect that really troubles me is who has the right to revoke. Because here we only discussed about legitimate users revoking credentials that needs to be revoked.
Yep.
What happens in the case where malicious actors revoke intentionally legitimate credentials?
So at the moment, only an issuer can revoke a credential. They need the private keys that they use to issue the credential to be able to revoke.
We have seen in the PKI trust model that some CAs starts getting rogue or starts being hacked. And what happens in that case? You'll have the same problem with the revocation process.
Yeah, so there's no, the beauty here is that there's no CA that has all the certificates, right? So the issuers have their own, but private key control and management is really important still.
So that, I think that's actually not inherent to the verifiable credentials data model, though, that only the issuer can revoke. So I think, for example, revocation mechanism is generic. So one approach that we outlined was, say I'm the recipient of a claim I don't want. I want to disavow it. It turns out in the verifiable credentials data model, I don't have to share it, but we set up something where it's like a smart contract basically that lets either the issuer or recipient revoke. But this isn't your question. So what you're getting at is the idea of, okay, so there's two things. Is it the issuer becomes malicious and decides to, okay, so that's one area, depending on how it's implemented, you could see the distributed ledger, having that distributed ledger as a benefit, right? Because you get to audit these revocation actions. So other parties get to observe, hey, the government of Syria suddenly revoked all of their, university degrees, right? And so in today's world, they get to be malicious behind the scenes and no one knows about it. Yeah.
If I may, I would like to because that was my concern yesterday when I asked the question. Right? I think I buy into your model, but what I miss, and we are in the FIGI security clinic, right? So this is what we should really do. What I miss is the security architecture behind, and we are not talking about it. What I would really like to see is something that says, okay, this is how the main flow works. All right, we have a great story, it's a great story, I buy it. But I would very much prefer to see, okay, to increase the levels of assurance and security we could provide, I would like to see things like, where do we put security? For what? How do we notify the different pieces that we have a breach somewhere, even temporarily? I don't want to quote any country, but some countries on the DNS have hijacked the entire DNS for 5 minutes. For 5 minutes, you have something that you trust, you cannot trust, because they were trying to find people against their regime or whatever to hunt them. So the problem that I miss in this whole discussion is, what does it look like? And as this time I will speak as working chairman of Study Group 70, that's exactly what we need.
Yeah.
We need you guys to help us, and I'm not saying it's not a critique. My point is to say, where are we on that? Because I don't have the answer. Until I get the answer, I need to push until I get it. If there is no answer, that's fine too, but just tell us.
Right.
Because in this case, we could, because we have another problem to discuss yesterday. Forget about what you are doing because what you are doing is pretty fundamental, and as we discussed with Andy, I think it goes way further than just identity and authentication. And it's pretty revolutionary, and I like it. But the flip side that you may not perceive is that cybersecurity as a whole, at ITU level, for all the member states, all the constituencies, all the actors, is in regression. We are not in progression, we are in regression in many ways. Right? And one key thing we are missing is, what is the overall foundation where we are? The only worldwide foundation for security architecture is X.800 series, which is 30 years old. So if you guys move this way, that's great, but you're going to create a bigger tension with a world that needs help, at the same time needs to understand what you need.
I have a lot of things to add. I don't have anything to write down, so before I lose a lot of things pushing on the stack. So I totally agree. So one thing I want to call out is that, well, so first of all, I think the slides that I prepared, we weren't sure what to present for this particular session, to be clear. We thought that it was, sort of more general, about this, so we're happy to talk about it. I think I will call out in general, I think it's at a very premature level. So the verifiable credentials data model, the decentralized identifier data model, the way that it's approached right now is in the specification, you'll see privacy and security spectrum guidelines, not necessarily best practices or how it aligns with. So I want to call that out, that I think it's very important to keep that in mind, that we're still, the base standards are still being worked on. And so so I think that's part of it. So what does that mean? Is that being paranoid as well, it terrifies me, the idea that we would throw out all the benefits being proposed, like, those by the FIDO framework, things like that. So I think that when you see these idealized pictures, that's sort of more of a, a teaching, or a sort of idealized version. In my mind, it's absolutely critical that this be introduced, like in working systems, it be introduced slowly, carefully, taking advantage of, hardware authentication. Like, I would not want to be part of a system that's, instantly throwing out everything we have right now and just basing it on blockchain. So I think it's very important to call that out. Do you have anything to add?
Yeah, I'm conscious I know you're not here this afternoon, right? Can I just show something? I'm just going to flip, risking the ire of the audiovisual people.
But while you do that, and just to keep, my point is that I like presentation because I like action.
Yeah.
Okay? What you are talking about is talking to my working party in my application security, or the application itself. I really wonder if you should not think about perhaps organizing a workshop for the next SG17 meeting about it, or a mini workshop, but not about anything, but about coordinating our actions, right? Because if you guys start something and we start something and we are diluting here, and I would like to stop that, and we work in collaboration.
I would love that.
We are not enough to tackle all of that, and we need to not resolve everything, but at least answer the big questions so that we can say, okay, now we, short term we do that, long term we do another code, and you sequence all of that. This is my view. So I pause at that. I'm sorry if I'm pushy, but
we should absolutely do that.
Yeah.
As Kim says, it is quite early days. I just want to share some early workings on something called the trust over IP stack. Okay? So we know what voice over IP is, right? What we've been talking about here is trust over IP. Although some people don't like that term because you could do trust over NFC and trust over Bluetooth as well, but let's just take trust over IP.
I just want to call out first, though, he's not going to like this, right? Because this is an example of reinventing all the stacks. But I want to bear that in mind, that this is not what you're talking about. This is, yes. So
it's to address it's to address particularly the governance piece, right?
Okay.
That's where I wanted to go with this. Is not push trust over IP as like Nirvana, but I want to show here that there's two pieces of trust. There's two types of trust. There's technical or computational trust or cryptographic trust, which is this bluish lot down here, which is all this stuff about DIDs and PKI and everything else. But above that, you need human trust, and you need mechanisms like a governance authority, auditors, maybe insurers, right? Have your credentials insured. Okay, now there's somebody who's setting up a business on insurance for verifiable credentials. Okay, so this is, it's early, but it's work underway, and some of the best thinking is going into the higher level governance frameworks and things that give you the human trust. And these things exist already, right? Visa is a big governance framework with a network to allow you to move payments around. But it has a set of rules, which, the Visa rules, this is how you become an issuer, you have to abide by these rules. If you don't abide by them, you get thrown out. Think of that as a governance framework. They already exist. The thing for doctor identity, the NHS already has rules for how they check a doctor is a doctor. So what you've got to do is translate these existing frameworks into this world of credentials and proofs somehow. So coming into Geneva, you have a passport. How do you know the passport's good? Because ICAO says the passport looks like this, and here's who issues passports, and these guys are good. That's human trust. And the technical trust is that the passport's got a chip on it that can be read, and there's some keys in it. So that same model of human and technical trust are being merged together. And an example of a governance framework is the one the Sovereign Foundation has, but there are going to be plenty of others as well. So I just wanted to pop that up just to let you know, because I'm going to talk about this afternoon, and I know you're not here.
So to touch on what you're saying, though, say like DIDCOM, that's an example of something where that's a new thing. You would have to, apply. We need more thinking around security model, things like that. But so keep in mind that like this model, having the sort of idea of the flexible governance frameworks that you can vary per domain, that part is critical. But I think we're very aware that at each level, every new standard that you introduce, you want to be very careful in the rollout of that. So,
yes. I think it's not only you want to be very careful, but it's an art race. So we are going to always have to find something there. I think the problem I miss here is that we don't have an architecture of security behind that. That's my, I don't know, that's what I observe. We don't have a mechanism, we don't have an integration cyber defense, we don't have an orchestration defense, we don't have, for example, I don't see how, for example, security practitioners can actually act on that. Because this is another human that is in the loop, that should be part of the governance phase. That means if the SOC that is looking after one part of it sees, oh, wait a minute, there's a breach here, how do we get that to other parts?
Yep.
I think let's follow up after, because I think that we can. I think we can provide. I think that's a different talk than what we prepared right now, and I want to make sure that I do want to make sure we're able to talk about more. We've spent a bit of time on this, so we'll follow up offline if that's okay.
Yeah, it's a really important topic.
Yes.
And of course, you and everyone here can contribute.
Yes.
So we haven't got all the answers.
Yeah.
But,
I should check
unless you know what the gaps are, you can't fill the gaps, right?
But I know in general, because it's like, I'm on the office of the CTO of the largest security company in the world since 30 years, so I'm not a security expert, as we discussed yesterday. Funnily enough, I'm a good designer. Mm-hmm. And I understand the state of this whole thing because of what happened to me over years. But my point is to say, agreed, we need to pause on that. I distracted you a lot from the presentation, but I'm pushy because I think this is the core of the problem. It's a security clinic. That should be what you should be discussing.
Yeah.
And so, sorry to be rude, but that's why I'm pushing. Now, I really let you continue. We can get that offline in a discussion.
Okay, excellent. Yes. So this I'd like to check in with the rest of the room. I'd like to check in with the rest of the room. So I mentioned, so we're getting near the sort of check-in point that I mentioned of going over the basics. I think we have a few things now. So let's see what else. We have a few. We could deep dive on decentralized identifiers, what those look like. We could talk about examples of verifiable credentials and DIDs. We could also continue, if this topic I don't mean to shut that down, because if this is a topic that's interesting to people, we can turn it more into a, collaborative session, right? So we have an hour left, it turns out. So what are people interested in? Are you into more of this, or?
I would be more into implementation details, especially the revocation process. But we can take it offline.
Okay.
We're actually, if you're here this afternoon, we can cover it. We're going into a bit more deeper detail this afternoon.
Yeah.
So I can show you some stuff.
Okay, so we will get back to that. We'll come back to that later.
If I may, I would be interested to really understand how technically the protocol works. Peer-to-peer, are you leveraging, existing protocols that? What's the relationship with DNS training? What's the relationship with DNS operations perhaps? Or what's the relationship with LS or FIGI or if any at all? I have no idea. So I would really like to understand how technically.
Yes.
Hi. I have my curiosity, if we have some time and a little bit of flexibility, and this could maybe take 5 or 10 minutes, is translating a lot of what you covered this morning to an absolutely non-technical audience, particularly in governments who are faced with implementation of this. So last week I was in Sierra Leone, where they have the Kiva protocol ID project underway, central bank governor, like what's going on? And so a lot of what you're talking about around DID and the nature of decentralized and how these security vulnerabilities have some trade-offs, but they're fundamentally better than some centralized options, particularly when they're as efficient as they currently exist. Where is that? What's that primer look like?
Yes.
Like what are the categories of issues, ideally in sequence, like start here, that you can give a little bit of comfort to relatively senior folks in government. Because what I'm finding is it's complex when certain institutions might have greater capacity and understanding than others, but they're mutually dependent on each other. Does that make sense? And we're stuck. I'm from UNCDF, the UN Capital Development Fund, and we're stuck in the middle, which is why I'm here. Yeah. But a lot of what you're saying, I think, could be translated at the right level to those audiences. I'm just not really sure where to start. And I'm definitely not the right person, so the question is...
No, and this happens a lot, and we pitch this, as Arno says, we're in a security clinic, so we're kind of gone a bit deep.
Yeah.
And it is really dependent on the audience that you're addressing. And I speak to everyone from chief information security officers at banks to UNHCR to Red Cross to, trying to simplify this stuff has actually been really hard. So I've been doing this 4 years now, trying to explain this to people. And we're kind of trying to get simpler and simpler and simpler. It's an interesting change has happened. The change has been going from wanting to do a really detailed analysis of the cryptographic functionality under here to what does it mean for my business, okay, or my organization. So what we're using more now is this term of digital watermarking, which a lot of cryptographers will kind of shudder at because it's not technically enough. But all we have here essentially is a way of moving information from A to B with some digital watermarks on it that allow the recipient to confirm the source, the integrity, and the validity of that data. Okay? That's essentially what it is. And that data could be anything. And the most common application is identity because everyone's interested in identity. But the information you move could be anything. So that's kind of how we talk about it. And we barely touch on distributed ledgers or blockchain stuff. 2 years ago, everyone was excited. We've got some blockchain pixie dust sprinkled over this thing. It's really exciting. Have some money. I wish. It's different to that now. It's about what's the business benefit? How does it change my business? So that's how we talk about it. And you then have to see, well, what's the audience? Well, it's a bank. Well, you're worried about regs for KYC for corporate and human onboarding, or you might be worried about secure customer authentication. Right? So how does it help that? So you then have to kind of do a translation. So the biggest problem we have explaining this is it's like in the early days of the internet, trying to explain what the internet would do. Okay. So if you'd have said, I don't know, 25 years ago, there you were with Tim Berners-Lee in the office there, and you say, oh, hey, Tim, what's the internet going to do? He's going to say, well, do you know, we're going to use it to share pictures of cats. All right? And what do you want to do? Or you could say, well, we're going to have a way of advertising that you've never seen before. I don't want to have that. And in reality, the internet has so many functions because you've got some open protocols under the skin and people are able to build on top of that. So here we've got something like that. You've got a set of open protocols, the implementation of which is still young and evolving, but it is open. And there's people piling in doing identity for pets, right? Identity for cars, credentials for crossing borders, credentials for doctors, because people are taking advantage of the open capability. So under the skin is this ability to securely connect and exchange verifiable data. And you can use that for whatever you want. And in some implementations, there's a blockchainy thing under there, which could be Ethereum or Bitcoin or Sovereign or what's the ION, the Microsoft Sidetree stuff or whatever. But all that is a store of public keys, right? It doesn't need to be a blockchain. It could be something else as long as you trust it. So that's kind of how we describe it now. So I hope that's helped. It is a real problem.
Yeah, no, I mean, I think the use cases are where to start, and that's extraordinarily helpful. I think that the question then is this sort of a now what? Like, what do I do as a decision maker? Yeah. How do I oversee that this is adhering to what my vision for it is?
Yeah.
And it's kind of, and maybe this is beyond this conversation, but like, how does that common baseline get, validated across so many people? So,
Do you mind if I could?
Yeah.
Yeah. So what's been happening this year through 2019 is the people who've been doing the technical due diligence, right? They're now it's come out of innovation labs and into the P&L owners of products in companies who are working out what they can do with it. Like, I can reduce my customer dropout in my checkout process by 10%, right? Or a customer who calls into the call center, we can authenticate them using DDoS in 10 seconds rather than asking them about their cat's first name in 80 seconds. So it's becoming business benefit, right? So what we've got is, during 2019, a number of proof points coming out, like the credit unions in the US doing it using authentication, like identity for doctors, like the project we have at the moment with the Financial Conduct Authority in the UK using credentials for bank onboarding. So you're now into use cases, and that gives people confidence that if it's good enough for doctors, then it's kind of good enough for nurses, and it's good enough for tower crane drivers, or it's good enough for onboarding any employee. And suddenly you've got an employee onboarding use case, right? And then if it's good enough for KYC for 5 UK banks, which it looks like it is, then it's good enough for all sorts. So these use case proof points are happening this year. Last year it was technical proof points. This year is use case proof points. And next year is going to be is the business value proof points, and that gives everyone confidence to go, well, it works there, so it's probably okay, right?
Yeah. So I think talking about some use cases might be good. So I'm going to start with this very simple, cutesy graphic, but then turn it into a project based on this that I'm familiar with. So the British Columbia Verifiable Organization project is they're using Sovereign, right?
Yeah, they're using the Live Sovereign network. This is a really good one.
Yeah, so there are a lot of interesting things going on. Essentially, some people with the British Columbia or BC Gov government, have issued for each organization decentralized identifiers and issued them verifiable credentials. I don't know the correct terminology, but basically you're a legitimate business kind of. Yeah. So this one shows some examples of the kinds of permits and kind of credentials that a business might want to get. So one of the benefits that they're noticing is that for businesses, it's enabling them to reduce the number of duplicate efforts. So right now when they apply for licenses, they're having to repeat information with this agency and that agency. And so this is making it easier for people to, audit and independently, compare, which also makes it easier on the government in turn to, improve their processes, right? So they know to align on this. They already got this thing. That means all I need is this. So there's some numbers they have about how much it's saving company. So small companies would be the biggest kind of companies to sort of realize these gains, because previously they were spending a lot of time on this, filing this paperwork. You might actually know the exact numbers.
So they've issued millions of credentials. These organizational credentials, and you can go on and look at them. Actually, I've just got the website open here, but if you look for Verifiable Organization Network, you'll be able to find it. Now, one of the criticisms often put against stuff using blockchains is that it's slow, transactions are slow, and all this kind of stuff. So in order to issue millions of organizational credentials, Ontario and British Columbia wrote to the sovereign ledger 9 times. That's it. Because the credentials aren't issued onto a ledger. Okay? So what they've written on the ledger is their issuer DIDs, their credential definitions, and credential schemas. So they wrote 9 entries on the ledger. So you could, if you wanted to issue a credential to everyone in the world, what you'd write on the ledger is 2 things. You'd write 3 things. You'd write your DID as an issuer. You'd write a credential schema, which is the map of what the attributes are in the credential, and you'd write a credential definition that has the public keys for each attribute. You'd write 3 times, and you could then issue 7 billion credentials without ever writing to the ledger. Because the credential exchange happens at the edge. Okay? The ledger is used from then on to read those things to verify if you exchange them that the keys are good and the signatures are good. So the Verifiable Organization Network is a really good example of mass issuance of credentials for organizations to confirm they are who they say they are. And it's a good example of the efficiency of scale, because you're not writing every transaction to the ledger.
And I have, go ahead. I'll give the example later.
No, I mean, so just to take away, sort of, if I understand what you're saying is, in a sense, focus is really on the underlying tech is on the underlying solution is around the credentialing, right? And so in the case of some of these governments, they're hyper focused on this is a replacement for passports. This is an identification scheme that could replace what we have. But what you're saying is you got to look one layer down, the whole internet analogy, to say, no, this is a more fundamental way of looking at how do we create these efficiencies, and using the British Columbia sort of as a GovTech compliance solution. Despite the fact, if I understand, the same processes are applied to other use cases. Does that sound kind of about right?
Yeah, it's like a foundational global utility.
Yeah.
And you use it for what you want. Just like you can create a website for any service you want, as long as it uses HTML, it's good, and browsers be able to read it, because those standards are there.
Yeah.
Here you've got a similar foundational utility, open standards, and you can build a pet ID thing on it, or you can build a doctor ID thing, or you can build a car-to-car information verification thing.
Okay.
So one example of what this enables, a specific BC Gov company, so they're C-SPAN, not the news place, but they make ships, a shipyard, so SEA span. So they are a BC Gov company, so they have a decentralized identifier. They have some of their company, credentials on the verifiable organization network that anyone can inspect. So Loki is an app that I worked with, and so effectively what they're trying to do, C-SPAN, they have a lot of big dangerous objects, and safety training is very important, but it's very hard right now for them to actually make sure that the tests are being performed, that they're being tracked, and things like that. So, for example, now C-SPAN can't really say, for example, how many of their employees have completed training in zones, and so there's a lot going on. So Loki is doing more than just verifiable credentials. So part of what they're doing is solving. Let me see. I might have a picture of it. So what they're doing is, a lot of 3D modeling of the space to, basically gamify safety training. And so they're part of their side business is testing the hypothesis of, do people retain information better in VR versus AR versus, because what we see as safety training right now are these sort of flat maps that no one reads. So, but for the people in C-SPAN, it's very critical that they do this. They have a lot of, they risk severe injuries. So, there's a lot of interesting kind of, gamification aspect going on to safety training. But at the end of the day, what they're doing is several things. So, when an employee completes their training, that employee can get a credential saying, yes, I completed my training. The other thing is, there's a system behind figuring out how many people have done their training, and the fire department, for example, safety inspectors might set criteria saying once 80% of people have completed their training, then that fits this other WorkSafe BC kind of certificate saying, you are a safe workspace, which that company can then use to get insurance discounts, things like that. So then at that point, what the system does is issue a credential saying, from the WorkSafe BC organization that you're a safe workspace, which lets us get insurance discounts, all kinds of things like that. So I have a little, this is an example of the kind of training that they're doing. But this is showing the idea that, so the company users are entering information about the space and the training, what sort of criteria the users need to complete. But then there's this offline process saying, the inspectors can inspect the state of the game and set criteria, say, this is what I need for you to be a safe workspace. So effectively, because of the challenges improving compliance now, in current manual days, very few companies are even getting this credential because the processes are so complicated. So the ability to inspect into saying like, okay, 85%, then they can, if they want to audit down to the individual records, for the individual, for the user, this gives a lot of value too. So, it's a heavily unionized place, and so the union is very, very critical. They're very concerned that the employee's safety is preserved. So, using a lot of principles that I think you talked about earlier with these pseudonymous DIDs, they can end up with a credential that basically says, I finished my training. They can prove it's about them, but they didn't have to reveal a whole bunch of information about it. So I wanted to call this out because this is one example where it's focusing on a business receiving value from it, receiving this WorkSafe credential, which in turn lets them get major insurance discounts and things like that. So
yeah. This is just a really good example of an implementation of the technology.
Yes.
That shows how it can be put into workflow, right? So there's three components of making any of this stuff successful. We call it the BLT sandwich: business, legal, and technical. So most of what we've been talking about here is the technical stuff, right? But if you don't get the business and the legal pieces, then no one's going to deploy it. So the business is, where does it fit in the business model, in the business process? The legal bit is, where's the liability commonly? Interestingly, we had a very big law firm who's been looking at the financial KYC stuff we've been doing with digital credentials, and they've concluded that there's no liability shift when you use a digital credential compared to me going in with a passport. So that's a fundamental, I wouldn't say ruling, it's a fundamental judgment, if you like, that if I'm coming along with a digital credential, all that's happening is the bearer of the data is changing from a piece of paper to a digital bearer with cryptographic signatures. The liability model stays the same. On the verifiable organization network, I wondered if it might be. Do you want me to do it? I'll do it over there.
Yes.
Orgbook.gov.bc. We're just going to show you what it looks like.
Yeah. I might have a screenshot to put up in the
I'll just show
meantime.
it.
Yeah.
I'm hoping I can do this.
So yeah, while he's pulling that up, this is, oh, perfect. Go ahead.
Okay, let's see if this works. Oh. Is it online still? Oh, there we go. Okay, I must have mistyped. Okay, so here is British Columbia's verifiable organisation network implementation. And we'll put in an organisation, a Canadian organisation. So one of them is, well, I was just going to use TELUS. So TELUS is the main mobile, or the main telecoms provider there. I could put anyone in, but it's only just check this works just now. So here's TELUS, right? And we can look at this record here. And what we'll see is some information about them related to TELUS communications. And look, they've got some credentials, okay? And here's a credential that says, I haven't tried this before, but here we go. There's another registration. So this is like a nested hierarchy. Here's a credential issuance. It's showing that this record TELUS is owned by TELUS Communications Inc. and it's active and it was issued on this date. Okay, so that's a credential. There's nothing scary about it. It's just a bunch of data. Okay. So let's just go back to organization. Oh, no, we want to look at the issuer. Who's the issuer of the credential? So there is British Columbia government's public DID. Okay? And that has their keys, the public keys for these credential definitions that they've issued, and away you go. So DID, : and this is the format that Kim spoke about. DID, it says it's a DID, SOV points to the sovereign ledger, and this blurb here is the location on the ledger you go to pull back the credential definition, the DID document, and so on that lets you verify any credential. So that's what it looks like. It's not scary, right? Pretty simple. Okay. Let's go back to the segment. Okay.
So any more questions at the moment? We could talk more about DID implementation of DIDs. I think that was brought up in your earlier
talk.
The
different methods. They'd be quite good, wouldn't they?
Yeah.
When DIDs were first designed, so a guy called Drummond Reed, he's Evonym's Chief Trust Officer, which is a kind of made-up title because we're trying to work out what to call him. So he did most of the DID spec, about 90% of it, and he designed it so it wasn't going to be specific to sovereign. It was going to be open, and you could have different methods because there could be different stores. You may want to use a different ledger for some reason. You may have a private implementation of Hyperledger Indy. You may have an Ethereum ledger because you're doing something as part of a smart contract. So DIDs were designed so you can have pointers to different stores, and that's the method which looks like SOV or BTCR or ETH and so on, to give it that flexibility. So this is where the openness comes in. DIDs as a standard can point. Oh, thank you. Yeah, can point to anyway. So yeah, here's some of them. Do you want to talk about some of these?
Yeah, actually, I was just sharing along with.
Yeah. Okay.
Yeah.
Oh, fantastic. So Sovereign as a ledger has been designed only for this purpose of being a global public DID repository. Essentially, it doesn't do anything else, right? There's no mining. You know, it's not got smart contracts in it. It's just a place for DIDs and stuff to go. Very's one is a similar thing. IPID, I haven't come across that one.
Yeah, IPID, so it's based on, actually...
Oh, it's an IPFS basically.
Yeah, it's based on IPFS. There's a couple ones. One of them is based on, so that one is, it's actually not a blockchain, it's IPFS. So you can have a DID that points to a location in IPFS that gives you this DID document. And I'm not sure, did we talk about DID documents yet?
No, we should do that.
Okay.
I said very briefly that a DID points to a DID document, but I didn't really say much about what's in.
Okay, let's do this then. Okay, so, and sorry the formatting got a little weird, but so this one, this DID up here, this DID string, that's an example of a BTCR DID. Yes.
It's the big green button. Not okay.
Sorry. Yes. So let me see.
Well, we got a section on use cases this afternoon.
Yes, we do have a section on use cases. I'm trying to think where. So we were actually getting towards the end of the prepared. So there was supposed to be another guy here presenting, and so we were getting to the end of the sort of prepared part. So because he was gone, I pulled in some extra stuff. So it's a little weird. But I think that I'm trying to think, like, we could either get into this or talk about that some more. I don't have finance background, so I don't know.
Yeah, what we could do, we could go to lunch, is option one, right? We could do a vote of the room. So we're meant to finish at 1. We can finish a bit early for this bit. But you're describing use cases, and maybe use cases is a way to go. So I've got the ability, assuming my PC stays running, to create credentials in real time and show you them. So if you've got a micro-lending use case, if you described what are you trying to fix, right? Then we can maybe put a little demo together, and I could issue you with a credential, and you could then go and use it to prove. So we could do something like that. I've got some pre-prepared demo stuff that has a bank, a driving license authority, passport authority, and a retailer, right? So I could show you that stuff. And we can talk about other use cases that we have as well. So some of that was going to come this afternoon. So this afternoon's session, there's 2 bits on it. One is about the sovereign trust framework. To be honest, that's going to be a bit dry. I think after lunch there might be some sleeping if I talk about the sovereign trust framework. And that's meant to be 2 hours, which is probably going to kill me. So maybe we just talk about use cases then, and then in the afternoon, well, after that is actually a session on use cases. So maybe we just bring the use case thing forward. Is anyone desperate to know about the sovereign trust framework? Okay, I'll take that as a no. And what's most valuable to you guys? We're here to tell you stuff and to help and educate. Yep. Oh. Yeah. Yeah. So if that agent was able to prove they were an agent to anyone at any time for anything. Yeah.
Yeah.
Yeah, that's exactly what the step that's happened is. It's kind of gone over the tech bit into the B and the L. Yeah. Okay.
And I'm not here this afternoon, so I'm not going to slow you down.
So it'll be much faster. This afternoon it'll be much faster. Yeah.
And it would be good if we can talk to your use case more, so we can jump on it.
To jump quickly into that, our use case is not really lending per se. However, we are trying to abstract several networks. We have the institutions that do the lending with their own money, and we have the borrowers. So there is a problem of people borrowing from so many institutions at the same time and exposing themselves to the reality of or rather the inability that they are not able to pay back, and with each subsequent institution that lends to them also exposing themselves to credit risk, because there is no centralized view of all exposures. So what we're trying to do is that we're trying to provide a unique identifier so that anyone who lends actually in bank terms, what they call charge. They will charge that identifier, or they'll tag it with a borrower. So any subsequent person who's lending can actually see how many people have tagged and for how much. And based on their decisioning models, they can decide whether to continue to lend or to decline. So instead of creating a new set of registries, what we are looking at is applying on top of what already exists. We have banks, we have mobile networks, we have other government institutions that provide, registry services. So how to create that overlay network with an ability to tap into the underlying other networks. So it's more like what we are looking at, and the objective is to provide a universal view so that you can understand the degree of exposure this person already has or doesn't have.
Very interesting. So this is what is really cool, right? So you go past the did stuff into how can you make it work in a use case like that? And the question I would have is, are you going to be asking people to reveal how much they've borrowed to someone else? Okay, so whether it's a digital credential or it's paper, you're asking someone to say, I've borrowed $1,000, can I have another 100? Okay. Whereas in actual fact, people will probably not want to reveal that because they want the money, right? So, and they're not worried about the debt yet because the debt collector hasn't turned up yet. So as I said earlier on, there's some things that this is not very good for, which is stuff that that people aren't going to want to reveal. Now, you could say something like, I'm going to give you a credential, which is a debt record credential, and every time you borrow some more, I'm going to give you a new one with the latest on it. And in order to get another loan, you must show me your debt credential. Perfectly feasible. You could do that. Or you could give me a credential with a borrower identity in, and whenever I go and want to borrow from somebody else, it says, please give me proof that you're a good borrower, and I give them the borrower identity, and then something happens behind the scenes to find out how much money is in there. So there's some quite interesting things that we could explore there. Yeah.
Human rights agree with that?
Exactly. Yeah. So that's the L bit. Would human rights agree with that? Can you force somebody to reveal something? So the tech, sure. Right? But whether somebody would say, oh, I haven't got a lender credential. They have, but they're not going to reveal it.
In most of East Africa, where I come from, we have credit reference bureaus. And once a person has defaulted, they're listed. And once they are listed, they are credit unworthy, right?
Yeah. So
essentially, there are those options that the person has until they default.
Yeah.
Once
okay,
they
so
default,
you've already got a blacklisting through the CRAs, right?
The reality is that it's not useful to wait until somebody's blacklisted to expose a lending business to additional credit risk. So sometimes you also need to protect the users because somebody could have some, precondition or some.
You see they're building up to.
Yes.
Yeah. It's like sort of betting, it just builds up and builds up.
Yeah.
Right?
Also, one of the real problems in Africa is people borrow to repay other loans. So he's not borrowing to do something good with it, but he misused the loan and they are trying to cover that. So they borrow one to pay the other. Now they have a bigger problem, and then they borrow again, and each one is accruing interest. So it's a real problem. And one of the key things that we've been able to identify is that we can actually stop them by, giving them sort of limits. Essentially, this is what that adds up to. But that is not the reason why it's not the real issue. The real issue is we're also trying to abstract away the cash out path. So anybody can lend to you and you can cash out from any other person. So how do you verify that person is who they say they are?
Yeah.
That is much easier.
Yeah.
So it's in two parts. The first part is what we said, and the second part is how to verify the identity of an individual to be who they say they are. I have credit from C4D of 100 euros, and I want to cash out. So you have to be able to identify and prove yourself, and the other party also has to be able to prove themselves, because what we're looking at is abstracting the agency networks so that anybody who meets a certain threshold can become an agent by just fulfilling a certain set of requirements, and they can claim it back. So I cash out for the person who has been able to, who is approved for the loan, and I can go and claim it back, so that points of access for a specific brand do not become a limitation as to why they cannot lend or they cannot provide service.
Yeah.
For the other part, not the identity part, there is a project that I'm familiar with where for warehouse receipts. So if someone were to give some amount of crop to a warehouse, and then they can use that as a collateral. Sorry, the word is failing me, for a loan. And so basically, with that solution, the way that they were approaching it was not to completely eliminate fraud, but to set an upper bound on fraud. So they were able to put an upper bound that was, at least much better than before. But so some aspects of it remind me of that. So there might be possible to elaborate along those lines. So we'll talk about that more. And you had a question?
I think those are great use cases, because last week we were talking about the consumer protection framework, right? Beyond financial services, just what is it like? What are consumer rights? What are consumer responsibilities? And there's some abstract concepts like fairness, responsibility, right? Appropriateness. And the use cases you're using are, the question I'm hearing is like, can the technology actually help us test for quality, which is a qualitative, subjective context? And in a regulator, how do you do that, right? And I mean, so in this case, if a credential was issued by, right now, mobile operators are in effect credentialing their agents, right? So it's got the right brand color, so you just associate that with sufficient uptime, and so, okay, I'll get money from that person, right?
Yep.
And so if a regulator were to go to an MNO and say, show me that you credential all your agents, I'm not setting the standard, there is one, would that be sufficient for compliance purposes, irrespective of the financial services use case? There's 1,000, it could be nurses, it could be 1,000 things. And then does that act as a proxy for quality, right?
Okay.
Which is sort of the next step.
Yeah, you've got to have human trust in the issuer of the credential.
Exactly.
If you don't have that, you're screwed anyway. The technology lets you put some data in the pipe, and you know that what comes in is what comes out. That's essentially, really simply, that's it, right? But if you put crap in, you'll get verified crap out. So you need to, so we've been talking to a whole bunch of universities, actually. I know you have as well. In Australia, there was Trump University.
Sorry.
And Trump University went out of business. Who'd have thought, right? And the degrees, but the reason they went out of business is because a lot of the courses were just made up, spoof courses. Who'd have thought? So therefore, I could have a degree from Trump University that could be presented as a piece of paper or a verifiable credential. Okay? But Kim, by the sound of it, probably wouldn't trust.
They're probably the best,
But I've done the
biggest
course.
degrees.
The biggest, yeah. No one's had degrees like this. So, but that's it. So if you have trust in the issuer, the tech gives you the pipe to make sure the data you're getting, it came from that issuer, and it's not been changed. Those things are meant to do that. But if you don't trust the issuer, and this is why we have these frameworks already in place, like banking for onboarding a new customer. The bank will set their risk profile to say, well, here comes a new customer, they're coming with a bunch of paper documentation. This is the sort of documentation I trust. It's a passport, it's a driving license, it's a piece of paper, it's a utility bill, right? I mean, there's no trust in a utility bill. The utility hasn't issued it as an identity document. But that combined with other things and another utility, so you've got two proofs of address, the bank creates that for their risk framework to accept in a new person, and that's how they do their risk profiling. If somebody comes with these things, multi-source identity with bits of paper, it's good enough to come in, right? So they're already deciding who the issuers are. The tech lets you know that the credential came from an issuer. So with a bit of paper, it could be photocopied, right? But here you know who the DID is, and the DID pertains to this utility company, and the data is good, right? So you know it's come from them. You still need to have that list of trusted issuers, and it will be different in different situations. So in your example of micro-lending, there will be people who credential the agents, and you need to have trust in them. And if somebody presents with a credential that says they're an agent that's not from one of those ones, then you can say, well, that's rubbish, right? So you need that human trust layer on top. Should we break lunch, do you think?
Yeah.
How are we thinking about breaking for lunch? Or we could go another 7 hours solid. Should we break for lunch? And then I think, I'm thinking we just go straight to use cases after lunch.
Okay, yeah.
Should we do that? We're going to change the agenda, right?
Yeah, we might have to see.
So we'll go straight to use cases, try to do some demos, hope the laptop stays running, maybe get you guys getting some credentials on your phones. See how that goes, all right? So we'll reconvene at 2 o'clock, and then we may finish early as well.
Nice.
For today. Thank you.
Thank you.